Hello, am I audible?
Yes, ma'am.
Okay. Okay, let's start the session. This is week 10 microelectronics device to circuit session. This is a problem solving session. I'm Arpita Biswas from IIT Jodhpur and I'm pursuing PhD in electrical engineering department. So this is more details about me. So here we are going to solve some of the numericals and some of the MCQ question. And please, before coming to the class, please go through the lecture video. So this is week 10, question number one. So the most suitable feedback topology for the voltage amplifier is first option is the current mixing and current sampling. Second is the current mixing and voltage sampling. Third is the voltage mixing and current sampling. And option D is the voltage mixing and voltage sampling. So there's no hurry. You take your time, go through the question carefully, and try to solve the question. So what is the right answer?
Voltage mixing and voltage sampling, ma'am.
Yes, option D is the right option. Good.
Ma'am, good afternoon.
Good afternoon. So this is question two. In a trans resistance amplifier, the input signal is dash and output signal is dash. First option is the voltage. Option B is the voltage current. Option C is the current voltage, and option D is the current.
Option C, ma'am.
Yes, option C is the right option. Current voltage. This is the question number three. The voltage mixing current sampling feedback topology is also known as shunt series, or shunt.
Ma'am, option A, ma'am. Series Shan.
Other students, what is the right answer?
Ma'am, A,
Is
ma'am. Option.
is this option A? Jen,
Ma'am,
what is the right answer?
voltage mixing, current sampling. Series, ma'am.
Yes, it is series. Uh, you can recheck the question. Okay. So the right answer is series. Option C. So this is the question number four. For an amplifier or any other system to be stable, its pole should be lie in the dash of the S-plane, left half, right half, or anywhere or center.
Option A, ma'am.
Yes, option A is the right answer, left half. Question number five. The input resistance of a voltage amplifier should be dash and its output resistance should be dash. It's high or high low or low high or low low.
Ma'am, high low, ma'am.
Yes, it is high low. Option B is the right answer. So, in input resistance of a voltage amplifier should be high, and its output resistance should be low. So next question number 6. An inverting amplifier has RF equal to 100 kilo ohm and R1 equal to 10 kilo ohm. Determine the amplifier circuit voltage gain. Assume the op-amp to be an ideal one. So what is the right answer?
Ma'am, 2 kilo ohms.
How to find out the voltage gain?
Ma'am, Ri is equal to minus Rf by AV, ma'am.
Anyone else? Manoj? Jen? How to find out? For inverting amplifier, you have to find out the voltage gain. And also assume the op-amp to be an ideal one.
Ma'am, answer is right, ma'am. Ma'am, if the answer is right, ma'am.
Jen, how to find out the voltage gain?
Minus RF by R1, ma'am.
Yes, the voltage gain is minus Rf by R1. Now tell me what is the right answer. So minus 100 kilo ohm by 10 kilo ohm. So the minus 10 is the right answer. If you have any doubt now, please go through the question carefully and go through the lecture also and recheck is this answer is true or false. So this is the question number 7. An ideal op-amp has dash common mode gain and dash open loop gain. So first option is 0 0, second option is 0 infinite, third option is infinite 0, or option D is the infinite infinite. For an ideal op-amp, dash has the common mode gain.
0 common mode gain and infinite open loop gain.
Open loop gain, yes. Option B is the right answer. Good. So ideal op-amp common mode is 0 and open loop gain infinite. Next question number 8. The phase shift offered by the positive feedback circuit either dash, while the phase shift in case of the negative feedback circuit is dash. So what is the right answer? There is no hurry, you take your time, but at least try.
Second option.
Okay, can you little bit explain?
Ma'am, and generally in gain, based on the gain, we will calculate, ma'am. For
Hmm.
positive, we will consider 0 or 360 degree, and for
Hmm.
negative, we will consider 180 degree, ma'am.
Yes. So the right option is option B. So phase shift offered by the positive feedback circuit, either 0 or 360. And whatever question we are solving here, now please go through it and try to solve the more and more question. This type of question you are going to face in your exam also. I'm just 180 degree. So this is 360, not that one. This is the question number 9. Positive feedback is employed in designing dash. First option is the power amplifier. Second option is the oscillator. Third option is the signal amplifiers, and option D is the operational amplifier.
Option B, ma'am.
Yes, option B is the right option. Good. This is the question number 10. The inverting op-amp configuration suffer from low gain, high power consumption, high input resistance, or low input resistance.
Option D.
Yes, option D is the right answer. Question number 10. Low input resistance. Next, question number 11. The gain of negative feedback for any amplifier is given by. So, which option is right?
Option B, ma'am.
Yes, option B. Question number 12. Which of the following feedback topologies reduces both input and output impedance? Series shunt, or shunt, or shunt series?
Option C, ma'am.
Yes, option C, the shunt. Next, question number 13. Closed loop gain. The question is from closed loop gain. An amplifier has open loop gain A equal to 500 and the feedback factor beta is equal to 0.02. So you have to find out the closed loop gain.
Ma'am, I got 45.45.
Yes, the right answer is. Other students are getting the same answer.
What is the answer, ma'am?
40
45. Yes,
point.
ma'am.
Yes, ma'am.
45.45. Okay, ma'am.
So how to calculate?
AF is equal
Ma'am,
to A by
A by
1 plus A beta.
Yes. So we are moving towards the question number 14. Bandwidth with feedback. An amplifier has bandwidth without feedback is 5 kilohertz and A beta equal to 9. So find out the new bandwidth with negative feedback.
Ma'am,
Yes.
ma'am 500 kilo వచ్చింది.
Yes. Other students are getting the same answer, or you try? I'm waiting. The answer is 500 kilohertz.
Yes, ma'am.
Jane, are you getting the same answer?
And what is the formula?
Anyone can explain how to find out?
Bandwidth with frequency is equal to
Mm-hmm.
bandwidth without
Bandwidth
frequency
into
into 1
bandwidth.
plus A beta.
Ma'am,
Yes.
bandwidth into 1 plus A beta ఉంది.
Bandwidth with feedback equal to bandwidth without feedback without feedback into 1 plus A beta. Without feedback, it is 50 hertz, 50 kilohertz. Sorry. Into 1 plus A beta 9. So 500 kilohertz. So this is the question number 15. If A is given, beta is given, find the ratio of percentage change in closed loop gain to the percentage change in the open loop gain. A is given, beta is given. You have to find out the ratio of percentage change in closed loop gain to the percentage change in open loop gain. At first, tell me how to find out this.
Ma'am, 1/6 ma'am.
Yes, 1 by 6. Jen, how to find out it?
There are a lot of process to do, ma'am.
Manoj, have you done?
Solving, ma'am.
Okay, try.
What is the formula to use, ma'am?
Okay. So anyone how to find out? Can you little bit explain? Or I will. Surya Sadvik. How you have find out?
Yes, ma'am. Ma'am, first I have taken AF equal to A by 1 plus A beta, ma'am.
Hmm.
Then I differentiate the loops into dA by dA into A by 1 plus A beta.
Okay. See, you can use this formula also. Is the changes. Okay. So what here telling? Find the ratio of percentage change in closed loop gain to the percentage change in open loop gain. Okay. This meant delta AF by AF by delta A by A. Right? The ratio of percentage change in closed loop gain. Closed loop means AF and to the percentage change in the open loop. Okay. So delta A by A. This is denotes as ACE. Okay. So this you have to find out. So the direct formula is 1 by 1 plus A beta. So 1 by 1 plus A beta. A value is given 500 and beta is given 0.01. So what is the answer? 1 by 6, or it is near about 0.1667. Is this clear?
How we are getting 1 by 1 plus A beta?
It is directly I have taken the formula, right? And Surya Sadhvik actually discuss about the how they have totally from initial stage they have calculated. Surya Sadhvik, can you repeat again how you have find out? Hello,
Yes, ma'am. Yes, ma'am.
can you repeat from the initial stage how you have find out? This is a direct formula how to find out this ACE. Okay, this ACE
Ma'am,
equal to 1 by, yes.
ma'am, I have differentiated the question into two parts, ma'am. I have derived the equations, ma'am, so that I cannot explain them, ma'am.
So from the initial stage you can explain now how you have find out which equation you have used.
This equation only, ma'am. You have told what equation I have used that only, ma'am.
Okay. Okay, if you have any doubt now from where this equation is coming in the next class also we can discuss if you want.
Okay, ma'am.
Okay. So this is the question number 16. For a voltage amplifier with R1 equal to 2 kilo ohm and R2 equal to 8 kilo ohm. So calculate the feedback factor beta. If R1 or R2 this resistance are given, so in that time how to find out the feedback factor?
The answer is 0.1.
Is this 0.1?
0.1 only, ma'am.
Okay, wait for others how they have find out. Jen and Manoj.
0.2, ma'am.
Okay, and Jen.
And what is the formula, ma'am?
Okay, Manoj, can you please explain how you have find out? So
Ma'am,
that
beta is equal to R1 by R1 plus R2.
yes, the direct formula is R of beta equal to R1 by R1 plus R2. So now tell me what is the answer. It is 2 by see if you know the equations how to find out, then just it will take, I think, more less than 1 minute to find out the answer. That's why I already told it in the lecture that please go through the lecture video which sir already shared in the class. So here is the beta. So next, question number 17. In a series shunt feedback amplifier, the input and output impedances respectively. First option both increases. Option B both decreases. Option C input increases, output decreases. Option D is the input decreases, output increases. So what is the right answer?
Option
Option
C.
C.
Yes, option C is the right answer. With the question number 18, in a series feedback amplifier, the effect of negative feedback on impedances is both input and output impedances decreases, both input and output impedances increases, and option C is the input decreases, output increases, and option D is the input increases, output decreases.
Option D, ma'am.
Option B, ma'am.
Option B.
Option
B.
B option.
yes, option B is the right answer. Question number 19. An amplifier has bandwidth without feedback is 40 kilohertz and loop gain A beta equal to 20. So find out the bandwidth without feedback. I think this type of question already we have solved.
Ma'am, 1000, ma'am. 1000 kilohertz.
Okay. Manoj and Jen.
Yes, ma'am. 1000 kilohertz.
Jen, have you
Yes,
calculated?
yes, ma'am. Getting the same answer.
Okay. So same formula. So this is the question number 20. When the A beta is greater than very greater than 1, the gain with feedback approximately equal beta A or 1 by beta or 0.
1 by beta, ma'am.
Yes, the answer is 1 by beta. The question number 21. The general transfer function of a two-pole amplifier is. So go through the options carefully and try to find out the answer.
Option A, ma'am.
Okay. Jen and Surya Satya.
Ma'am, I think option A, ma'am.
Yes. The right answer is option A. This is the question number 2. For two-pole amplifier, the following data is given. Omega 0 is 200 rad per second and bandwidth is 1000 rad per second. So find out the Q factor.
Ma'am, 2, ma'am.
Option answer 2, ma'am.
2,
Okay.
ma'am.
So Jen, how to find out this Q factor?
Omega naught by bandwidth, ma'am.
Yes. So omega naught by bandwidth. Sorry, this is on the rad, okay? Rad per second, and this is 1000. So the Q factor is 2. So next question number 23. An amplifier has initial pole frequency WP is 5 k rad per second and A beta equal to 9. So find out the new pole frequency WPF with feedback.
Ma'am, I got 50 kilojoules.
Yes, 50 kilo k rad per
Okay, right.
second. Okay, wait for other students also, Manoj and Jen. Please try to solve.
And can you say the formula?
50K radian per second, ma'am.
Yes. So tell me the formula how to find out the WPF with feedback.
WPF is equal to WP into 1 plus A beta.
Hmm. With feedback equal to without feedback into 1 plus A beta. Okay. I think this type of question we have
Okay.
solved for the bandwidth also
Yes, ma'am.
with feedback.
What is the answer, ma'am? Is it 50?
Yes, 50 k rad per
Oh,
second.
okay, ma'am.
This is the question number 24. The magnitude of loop gain at omega equal to 180 is mod of A beta equal to 0.2 and find the gain margin in dB.
Ma'am, I got answer 13.98 dB, ma'am.
Yes, the right answer is 13.98. Manoj and Jen, please try to solve this.
Formula, ma'am.
Manoj,
Ma'am, 13.98 dB.
can you explain how you have calculated?
Ma'am, gain margin is equal to 20 log of 1 by A beta modulus.
Yes, the gain margin equal to 20 log 10 base 1 by mod of A beta. So 20 log of 1 by 20 log of 5. 20 into 0.699. So the answer is 13.98.
Okay.
Okay. So next
Okay.
question is an unity gain frequency. The loop gain has phase shift of minus 150 degree. Find out the phase margin.
Ma'am, 30, ma'am.
Yes. Manoj,
Yes,
Jan,
ma'am, 30 ma'am.
tell me how to find out.
Phase margin is equal to 180 plus phi of W, ma'am. That is minus 150.
Or we can write 180 minus
Minus 150.
mod of 180 minus of mod of phase at unity gain. Phase at unity gain. Okay. So 180 minus this mod of this minus 50. So it is only 150. Sorry, 150. So the answer is 30. 30 degree.
Okay, ma'am.
So the next question is an amplifier has open loop gain A equal to 10 to the power 4 and feedback factor beta is 0.02. Find out the closed loop gain. I think this is very easy. The simple question. Tell me how to find out the closed loop gain.
A by 1 plus A beta, ma'am.
Simple. Tell me the answer. Solve it.
49.75.
Yes, 49 point almost 8. 1 by 1 plus EBITDA. $201, I think. Yes. So it is almost 49.8. So this is the question number 27. If phase margin is 0, the amplifier will first option be highly stable, second is exhibit the sustained oscillations, option C have maximum damping, and option D is have infinite bandwidth.
Option B, ma'am. Which type of name?
Yes, option B is the right answer. Question number 28. An op-amp essentially amplifies first option the average of two input voltage. Option B is the product of two input voltages. Option C is the difference between two input voltages, and option D is the ratio of two input voltages.
Option C, ma'am.
Yes, option C, the
C.
difference between two input voltages. Question number 29. In an ideal op-amp, the input impedance is 0, output impedance is infinite. Or option B is input impedance is infinite, output impedance is 0. And option C is the input impedance is finite and output impedance is finite. And option
Ma'am,
D is both infinite.
Option B,
ma'am,
ma'am.
option B. Option B, ma'am.
Yes, question number 29, the option B. The input impedance is infinite and the output impedance is 0. Question number 30, the common mode input voltage is given by VCM equal to V1 minus V2, or VCM equal to V2 minus V1, or VCM equal to V1 plus V2 by 2, or VCM equal to V1 into V2.
Ma'am, option C, ma'am. VCM is 1 plus 50 by 2.
Yes. In the question number 31, the general expression for the output of an op-amp is. So what is the right answer?
Option B, ma'am.
Okay, Manojan Jain, is this the right answer?
Yes, ma'am. Option B.
Yes. Question number 32, an inverting op-amp R1 equal to 2 kilo ohm, R2 equal to 8 kilo ohm. So find out the closed loop gain. So it is an inverting op-amp.
Minus
Minus
4,
4,
ma'am.
ma'am.
Minus
Yes,
4, ma'am.
minus 4. Tell me how you have calculated the closed loop gain equal
Minus
to
R2 by minus R2 by R1.
minus R2 by R1. Good. So this is minus 4. Next, in non-inverting amplifier, R1 and R2 given, so find out the closed loop gain for non-inverting. Tell me how to find out.
think answer 10, ma'am, I think.
Yes, 10. Manoj and Jain, how to find out this?
Ma'am,
Ma'am,
1
A
plus
is equal to
Hmm.
1 plus R2 by R1.
Yes, because it is non-inverting. So it is 1 plus R2 by R1. So next question. Open loop phase at unity gain frequency is minus 150. Compute the phase margin. We already solved this type of question. Tell me
40
how.
degree, ma'am.
Yes,
40,
40.
ma'am.
180 minus phase at unity. Mod of phase out unity. Okay. So this is 180 minus mod of 140 minus 140 minus 140 degree. So this is 40. So this is the last question. An op-amp has GVW is 2 megahertz, the unity gain bandwidth. You use it in a closed loop non-inverting configuration with the gain equal to 20. So estimate the closed loop bandwidth FCL.
Ma'am, 0.1 megahertz.
Okay, and other students,
0.1 megahertz, ma'am.
tell me how to find out.
Ma'am, FCL is equal to GBW by G, ma'am.
Okay, so the answer is FCL equal to GBW G. So it is megahertz 2.56 and G is equal to only 20, right? So it is 10,000 hertz. I think 5, right? 1, 2, 3. It's 5 hertz. So 1000 kilohertz, we can write it. Sorry, 100 kilohertz. 100 kilohertz. Kilometer. FCL equal to. Okay, so we are ending the session here. Next class we will meet next Tuesday, 7 to 9 p.m. Thank you. Today class,
Ma'am,
I have only taken this 35 question. Yes,
ma'am,
yes.
in the exam, what pattern of questions will be asked, ma'am? Choose and numerical what we are solving that like pattern will be asked, ma'am.
This type of question, actually, I think the assignment type of question. This type of question we are solving here now, the assignment. I think the first 10 to 12 question I have taken the previous assignment.
Okay,
So
ma'am.
I think this type of question can come.
Generally, we will fill assignments in choose format only, ma'am.
Not only the assignment, but this type of question, like 20 to 30% question. If you go through all the assignment question, I think 20 to 30% question you can easily solve, and the similar type of question you can solve, like some of
Yes,
the
ma'am.
numericals and some of the like
Oh,
MCQ type of some theoretical portion they can ask.
okay, ma'am. Thank you, ma'am.
Okay,
Thank you, ma'am.
thank you.
Ma'am, when will we release hall tickets, ma'am?
Sorry,
When will they release hall tickets, ma'am?
when you will receive?
Ma'am, when will they release hall tickets, ma'am? Hall tickets, ma'am.
Sorry, can you write, please? I'm not getting.
Hall ticket, ma'am. He's asking about hall
Hey,
ticket.
actually, I'm not sure about it.
Okay, ma'am. Okay.